And yes, this webinar will be recorded. So the recording and all of the materials will be available. In particular, we're trying to make this webinar as broadly useful as possible. And so we have the slides that I'm presenting from available to you at this URL, which the TAs will be sharing in the chat. And I'll be popping that up throughout. This is going to provide the recipes for you to follow along with me. And at the end, we'll also provide all of the code that I generate in the live demos. Okay, so in order to make this webinar useful for you all, I encourage you to ask whatever questions you have throughout. You can do that using the Q&A functionality. So when you ask a question, Angie and Alvin will either answer that question or will put it on hold for me or them to answer during the Q&A periods that come at the end of each section. You can upvote questions that you also have. That helps us because then we know that that question is important and it keeps there from being many redundant questions. You can comment or clarify your questions if you want as well. So please do make use of that Q&A functionality as you go through this material. All right, and the last thing I want to mention with respect to resources is that this webinar is part of a broader set of approaches to reproducible and replicable science and open science more generally, which goes under the name Experimentology. This is a new textbook that is free and open source and available on the web that I and my collaborators have written over the past couple of years. You can see it at experimentology.io. So it's live in a draft form, but will be published by MIT Press, hopefully later this year or next year. This textbook contains much of the material in this webinar, as well as a lot of other material around project management, reproducibility and replicability, as well as basic experimental design and statistics. So please do check this out if you're interested in this broader set of approaches to open science. Great, let's get started. Okay, so this is the crest of the Royal Society, nullius in verba, nothing in words alone. The idea is that the scientific enterprise is built on being able to independently verify individual observations so that we can have a cumulative science, one that builds up on literally standing on the shoulders of other results, other scientists. So independent verification is a core principle of the scientific endeavor. And in the recent meta-science literature, thinking about this idea of verification, we've come up with different components of this verifiability. So this is a kind of rough sketch of the idea that if we have the same data set, we want to be able to get the same numbers out when we do the same analysis. When we do that, we call that reproducible. That's our upper left-hand corner. Sometimes that goes by the name computational reproducibility, getting the same numbers from the same computations. Reproducibility, but it's all basically the same thing. If you collect new data, but you do the same analysis and you get the same finding, we call that finding replicable. And of course, there's a lot of weight being put here on same, and we'll get into that a little bit today, but much of the discussion around replication, collecting new data sets, has been around that definition of same. And finally, you might be interested in an analysis that is robust across different specifications. So if you do different versions of the same analysis on the same data set, you'd want to get something similar in terms of a finding. But today we're going to be focusing on computational reproducibility, just simply getting the same numbers when you do the same analysis on the same data. I think we all should be able to agree that that is a good thing. If you don't know where the numbers in a paper came from, or you can't get them again using the same data, that's problematic for the scientific enterprise. And reproducibility can fail when there are analytic errors, when something was coded wrong or executed wrong in the analysis. But reproducibility can also fail when the data are not available, because without the data, you simply can't reproduce an analysis, or when the analyses aren't fully specified. You don't have all the details you need to put things together. A key notion in understanding analytic reproducibility is the notion of an analytic pipeline or chain. We start with raw data. These are digitized, often processed and pre-processed, filtered, munged, analyzed, and then written up and disseminated. So the way my collaborator Tom Hardwick says is, you got to remember Fleetwood Mac's famous Rumors album, you never break the chain. You want to be able to ensure the integrity of this chain from raw data to reported results, so that you can always go back and look along the chain to figure out where a particular aspect of the result originated, whether there was an error or whether there's an interesting finding you want to follow up on. So ensuring the integrity of this chain is a goal for our work on analytic reproducibility. And a bunch of interrelated reproducibility issues come up here. So on the internal side, when we're doing our own science, we want to maintain the integrity of this analytic chain so that we know where our results came from. We know that we started with our raw data and, okay, this is how we got to our findings. One way to think about this is that analytic reproducibility practices are communicating with a future version of yourself, because you now know what you did to achieve a particular result, but you may not remember that in the future. So documenting it extensively is really important to communicate to future you, who's going to thank you for this. But the second need is what you might call external reproducibility. Other scientists need to be able to access the details of the analytic chain and to verify individual steps. They can do that to check, to make sure that a result is correct. They could also do it potentially to explore alternatives or build on your results or use your analyses in different ways. So there are many cumulative motivations for looking into analytic reproducibility, as well as just auditing or error checking. Okay, and one solution to this problem is reproducible writing, and that's what we're going to be talking about today. The basic idea here, this is about as simple as it gets, is we're going to take an RMarkdown write-up, which is a combination of text and code. We're going to put that together with some data, which are typically stored in a CSV or some other tabular data format, and compile those using the magic of RStudio, RMarkdown, the knitter package, and so forth. And that's going to come out as an APA paper that you can submit to a journal. And so then when you share your RMarkdown and your data, that's going to give you the components of analytic reproducibility. So you've both documented what you did, which is actually going to save you time, and also you've made available all the code and data necessary to reproduce all of your results. And that's a very exciting package. So that's why I want to teach you these skills, because I think they solve some of the basic problems of reproducibility that otherwise can be very tricky and pernicious. One additional selfish motivation, though, is that analytic reproducibility practices are actually better for you as a scientist. It's not just about eating your vegetables, even though you don't want to do this, you have to. NIH says you need to be sharing your data. It actually also makes your workflow faster and better. I don't know if you're like me, did you ever hand tweak a figure? So you generate the figure in some software, then you tweak it in Illustrator or Photoshop just to make it look really nice. You don't change anything except formatting, but you do a lot of extra work. And then, your collaborator, your PI says, actually, could you redo it with this different analysis, different styling? You have to regenerate the figure and redo all of that tweaking. That's a huge pain. Or maybe you write in Microsoft Word or Google Docs and you copy and paste in your stats or your tables and you round those by hand. But then your analysis changes. You made an error upstream and you have to repaste and reround all those numbers, or reformat your references to change to a different journal. These are a huge pain. They're a huge waste of time and effort, and a reproducible workflow eliminates many of these tedious tasks, making the process of writing easier and more important. Shruti says they just did this for an R&R, and it's a huge waste of time. I completely agree. And this workflow that I'm teaching today will decrease or eliminate many of these. Okay, so the agenda for today. First, I'm going to talk a little bit more about analytic reproducibility challenges, so you get a sense of the meta-science literature. In the next section, that's going to be our practicum. We're going to use RMarkdown to create reproducible documents to address these challenges. Third section, we're going to go a little more advanced and explore RMarkdown for APA formatting and bibliographic management. And then we'll end with some open Q&A. This is a little bit flexible on time, depending on how many questions we take throughout. So let's get started. The basic observation that I want to convince you of, and it's not a fun observation, so I'm sorry that I'm going to walk you through this in detail, but the observation is that errors in data analysis are more common than we would like, and they are actually hard to find. So I know this really the hard way. This is my first paper published in Developmental Science in 2009. There's a wonderful graduate student, John Slemmer, who passed away midway through his series of experiments with Gary Marcus and Scott Johnson. I was the lab manager. I took over and completed the sequence of experiments, analyzed the data, and wrote the paper. And the key figure in the key experiment is this one. When infants, 5-month-olds, were exposed to multimodal rules in both vision and language tokens, like ba, di, di, with circle, triangle, triangle. They then were able to notice when the rule was violated with a new token, compared with when the rule was, the example that they saw with the new tokens was congruent with the rule. So you got a classic dishabituation finding on the first test trial, and that didn't happen with unimodal rules. I saw this paper a million times. I generated this graph. My co-authors saw this paper and the graph. The editor and 2 expert reviewers saw this graph, and none of us noticed that it was prima facie wrong, right? So if you look at these habituation times, they're extremely short, and they dip down essentially to 0. They're way shorter than the test trial times, which should be essentially comparable to them. So there's something clearly wrong here, which I did not notice. In fact, I only noticed this issue when somebody was critiquing this paper on completely different grounds. They hated the theory in the paper. They didn't notice that the graph was wrong. But when I reread it, I noticed that the graph was wrong. This was 4 years later. And my co-authors and I issued an erratum where we corrected this. Here's the corrected graph, which now looks like a reasonable habituation curve. Infants attended to the rules for almost a minute the first time, and then that gradually went down to the level that was right about similar to the congruent test trials, which after all are really very similar to the habituation trials. So this looks much better. When I dug into the workflow that led to this error, my workflow was that I got the Excel data from the habituation program we were using. I wrote a bunch of MATLAB code to work with it. Then I exported the figure as an EPS file and tweaked it in Illustrator to format the different panels, and then I dragged the whole thing into Word. And luckily, I had the MATLAB code that I used for these experiments, and basically the issue in this somewhat spaghetti code, look, this is not very well written, it's kind of hard to read, and the fact that I had written HM7, HM8, HM9 through HM12 meant that I had used the wrong trial numbers, but there was nothing to tell me that anywhere in the code. The only thing that would have told me that is using common sense at looking at the graph, which I clearly didn't exercise. So this was quite sad for me, and it was a real wake-up call that the workflows I was using were not sufficient for me to detect errors, and it actually led to a huge amount of changes in my practices, which continue to shape what I do today. But this is not just me. In my graduate class on experimental methods, students reproduce and replicate examples in the published literature that they are excited about for their own research. And here's the kind of code that we often see in these published papers. When they provide code, the code looks like this. So I don't know if you know more than me, but recall 1 equals 0 if Q21 equals 1, and then Q21 equals 3, 5, or 6. I don't know what any of this means, and I doubt the authors do either. It's very hard to check code like this, even though you have the code. And when we finally checked and rewrote this code, it turned out that the original code was incorrect. It had a typo in it because this was very, very difficult to verify. So Ken Lewis and Andrew Lampinen are responsible for this checking, and it led to a corrigendum, an erratum, which actually really changed the results of this paper. Just quickly addressing in the chat, Aaron, you asked about the syllabus for that class. Actually, in the experimentology.io link, you'll see the textbook for that class, as well as a variety of sample syllabi for classes of different formats. So there's a plus R coding, without our coding for a quarter long, or a semester long sequence. So we provide a bunch of sample syllabi. Great. Okay, so this is another example of an error, and this happens pervasively, at least in published examples. So one famous example is the Reinhart-Rogoff paper, which was an economic analysis that led to policies promoting austerity after the financial crisis. Unfortunately, when the original Excel spreadsheet was shared, it turned out that there were some formula errors in the spreadsheet. And this stuff is so well known that, in fact, there are cartoons about it, right? This is a parody. Never look in somebody else's documents folder, or else you might find what kind of organization they have underlying their file system. which of course means that if if the file system is disorganized, they may not really know the provenance of any particular analysis or data file. Okay, this is fine. So these are some kind of cherry-picked bad examples, but I want to point out that these examples are actually the best case, because the reason why I'm telling you about them is that we've detected them and corrected them. We have access to the code and the data, and we can figure out what went wrong and tell the world about it. In fact, that's relatively unusual because most data is not available. We don't have the raw materials to do this kind of analytic reproducibility. So we don't know the full extent of these problems. When we look at a general sample of the code and data availability, this now lags a couple of years because these things take some time to do. We see that it's very, very low in psychology and the social sciences. And many journals say, hey, you can do analytic reproducibility, you just have to request the data. But it turns out when you write to people and request the data for journals which have an explicit policy of data available on request, you don't get the data most of the time. Here are a bunch of different efforts where folks systematically reached out to ask about reproducibility for data sharing, and the data were not shared the vast majority of the time. So what do we do to figure out the extent of the analytic reproducibility issue? Well, here's one clever workaround by Baker and Weikertz. They take advantage of the idea that when you report statistics in APA format, you report 3 numbers: degrees of freedom, test statistic, and p-value. This is actually redundant. If you have any 2 of these, you can compute the 3rd. So you can actually check whether the statistics are prima facie correct by taking 2 and computing the 3rd. And if they don't match up, then there's clearly an error somewhere. Of course, there could be other errors that didn't lead to inconsistencies, but this gives you a lower bound. And when they did this originally with a sample of papers, it turned out that around 15 to 20% of the test statistics that were reported had some kind of basic error in them. Some of these, in fact, even were gross errors that led to changes in whether the result should have been reported as statistically significant. Yeah, I agree, totally terrifying. So Michelle Nuiten and the Weikertz group conducted a larger scale analysis by parsing PDFs for these APA formatted statistics, again, to give you a lower bound on total errors. This is using the stat check technique. You can actually go to statcheck.io and get a list of a sort of tool that you can put your PDF into, and it'll scrape out your statistics to see if you have these errors. And the key finding here is that in all APA journals, over time, about half of all papers have some sort of inconsistent reporting issue. Now, this doesn't mean that these papers are wrong. Many of these are typos or rounding errors or other issues. It simply means that there are analytic reproducibility issues. That is different than undermining the analytic conclusions of the papers. But for me, it still gives me pause about a paper when I learn that it has 1 or more significant errors in it. And probably some of these lead to changes in interpretation. So here's just one other way of looking at the depth of the analytic reproducibility issue. And I'm showing you this study in a little bit of depth because it really radicalized me a bit more about these workflow issues. And doing the study actually caused me to start teaching workshops like this one. So this was led by Tom Hardwick, who's a postdoc at the Meta Research Innovation Center at Stanford at the time, worked with me. And we were inspired by this open data policy at the journal Cognition around 2015. This meant that we had open data sets for many published papers that we could evaluate for reproducibility. And that's precisely what we did. So Tom convened a large group of folks to spend the large amount of time together, these hackathons with a pizza, sitting around trying to figure out how to get analyses reproduced from these open data sets. And this was the first systematic case study of analytic reproducibility in psychology. So we ended up doing this for 35 articles. 2 analysts took these articles that had previously been coded as having open reusable data and here are all the target test statistics or target statistics from these papers. So you've got ends, confidence intervals, miscellaneous, means, degrees of freedom, effect size, test statistics, standard deviations or standard errors, p-values, and so forth. And a circle here means a reproducible value, a value that we did get by writing code on the original data. And an X means that there was a non-reproducible value. In this sample of 35 papers, 11 were fully reproducible. 11 were reproducible with assistance, meaning we had to reach out to the authors and they all responded and helped us. And then 13 out of 35 were not fully reproducible, even with the author's assistance. That is, neither we nor the authors knew how they got those numbers for the confidence interval that they reported. It wasn't their formula, it wasn't our formula, we don't know what happened. So we checked about 1,300 values and there were 64 major numerical errors, which were off by more than 5%. There's an important caveat here. There are no cases where the reproducibility issues necessarily undermine the substantive conclusions, although there were 3 cases here where we weren't sure and the authors indicated that they might submit a corrigendum or an erratum. These things took forever, 2 to 4 hours for the easy ones and 5 to 25 hours for the harder ones, with 2 analysts, typically a student or postdoc, and then me or Tom or Maya Mather, who's a biostatistician and collaborator on this work. The way Tom describes this is like putting together a flat pack furniture with a vague instruction manual. It has a very high failure rate. Okay, and just to show you, because we did this work, we also replicated this reproducibility study. So we did it 25 papers from the journal Psychological Science that got the open data badge, and we found basically the same thing. About a third of papers were reproducible in all numbers without assistance from the author, and another third required author assistance. Okay, so to summarize, we talked about 2 components of reproducibility here. You need code and data for others to verify and build on your work. And then you need a reproducible workflow so that you can check what's happening with your work. So for this first point, I think it's clear from our work that transparency policies must require code and data. Even just having raw data was not enough for us to consistently reproduce all of the numerical results in papers. And for an individual, what I think this means is that if you take these results seriously, you need to post your code and data. And that's a tricky thing to get used to, but I think I hope that by the end of this webinar, you'll see one approach for doing so that's quite easy to do. And as you post your code and data, I think you'll come to appreciate some of the benefits of it, which is that people actually build on your work more frequently when you share these materials, and you achieve some efficiency gains when you have to go back to your work in revision or to revisit it in a new project. So you actually can make yourself more efficient as well as more reproducible. And of course, in order to do this, you need a reproducible workflow. And that's the reproducible reports that we're going to be talking about here. So we're getting some great questions that I'm going to answer live, since now is a good time. So Caitlin asks about dealing with data cleaning and removing PHI or private health information before sharing. So if we think about this analytic chain from raw data to report, our advice is to share the maximal part of this chain that you can for privacy concerns. For some kind of data sets, including many that we report, that's most of the chain, everything except the raw identifiable sociodemographic information and personally identifying information. So we remove those fields from the very rawest data before we share them out. So for example, we share only rounded ages rather than date of birth and date of test, which can be uniquely identifying. So for that sort of data, we have relatively limited issues. For other data which have more identifying information, for example, videos, you can consider sharing the videos in a more limited way, for example, via Databrary, and then sharing the coded spreadsheets in a more open way. And for very identifiable information, at a minimum, you can share tabular summaries that allow you to do statistical analyses and produce graphs. So you don't have to always share the entire chain. You can share the bottom half or the bottom 2/3 effectively. And there's some guidance on this in our data sharing materials in experimentology, as well as maybe the TAs can share our transparency and openness guide from Collabora in 2018. This is Klein et al. Okay, and Anna asks, can you share rules you follow to share data? Very helpful for IRB to know these practices. This is a tricky question, and it's going to vary depending on your regulatory framework. So in the US regulatory framework, we have the rules restricting research and rules restricting the sharing of private health information, and those overlap in different ways. But both of them are satisfied if the data are de-identified according to a list of key identifiers. So we use what's called the safe harbor standard of the Department of Health and Human Services. That's a list of 18 fields that can't appear in your data, and if they don't appear in your data, you can consider this de-identified. So all the data we share are de-identified. They are not PHI, private health information. They're not PII, personally identifying information. And so actually that data sharing is not governed by IRB because they are not considered by US regulatory practices to be human subjects data anymore. They're fully de-identified. In the European context, this is a bit trickier because of the Generalized Data Protection Law, GDPR. And under GDPR, there are two bits that are tricky, and I'm not a lawyer here. The first tricky bit is in principle, re-identifiability is important. So you need to know whether there are keys to get back to the identity of individual participants. And then there's also the right to be forgotten. You need to be able to let people delete themselves from the data set. So I'm not a lawyer. I can't tell you how to navigate GDPR, but those, in general, strong de-identification is the way we go for data sharing. And I think you can push back on an IRB that says de-identified data can't be shared by saying these aren't even human subjects data anymore. The name of those 18 criteria are the DHHS safe harbor criteria. And you could, if you Google that, you should get these guidelines. Okay. And we got an answer about a question from Molly about sampling for reproducibility analyses. So it's a great question. For the cognition open data paper, we actually sampled all of the papers in the pre and post policy period, and we coded them for the availability of data and the in principle reusability of the data. This was kind of study one of that paper, and then we randomly sampled from the reusable data sets in there. So there is random sampling within cognition papers in that period. In the psych science one, we did something similar, but using the badge system. So these are population estimates for a particular time period for a particular journal. Okay, let's move forward. So our next portion is using RMarkdown to create reproducible documents. So I want to make sure that we get our polls launched here. So I just want to find out whether you're going to follow along with our examples using Posit Cloud. So we sent out the link to Posit Cloud here, and it seems like now most folks are planning on following along, which is great. So now is a good time to load up your Posit Cloud session. Okay. So the key tools that we're going to be using are R, the open source statistical programming language, and RStudio, the integrated development environment for R, or IDE for R. RStudio is a great way to use R. It gives you a very nice interface to write R in and see the output. So I really strongly recommend that you use RStudio. Both of these are free and can be downloaded to your computer. But there's a caveat here. When I typically run these workshops, folks have R and RStudio on their computers, but they've downloaded them at different times. They have different permissions on their computers, and things go badly wrong when you try to install new software online. So today, we're actually going to be using a cloud-based service called Posit Cloud. Posit Cloud is the same company that makes RStudio. They confusingly renamed themselves Posit Cloud or Posit because they don't want to just do R, they want to do Python too. So here's the key issue. R is an extensible programming language. It relies on this ecosystem of packages, which are extensions to the language that allow you to do different things like statistical models, knitting reproducible reports, and all kinds of cool stuff. But downloading these and installing them is complex and computer dependent. So we're going to use Posit Cloud, this freemium cloud service that allows you to make an account and sign in and open up RStudio in your browser. And hopefully that's going to allow all of us to do this at once using the same computer. So the same kind of installation of RStudio. So we won't have some of these issues. Okay. So now let me describe in the abstract a couple of the tools here that we're going to be using. This is just to give you some background so that when you see a bunch of code and text mixed together, you'll have some of the ideas that will help you parse it. So RMarkdown is R plus Markdown. What is Markdown though? Markdown is just text with very, very lightweight annotations. It's a really simple way to make text look good. So if you want italics, you put stars around it. If you want bold, you put 2 stars around it. If you want a first level heading, like a really big heading, like introduction, you put hashtag. If you want a second level heading, like, methods is the first level, participants is maybe the second level, then you put it with 2 hashtags and 3 hashtags for third level. And that's really it. Markdown is just a kind of consistent way of marking up text to format it in a lightweight way. So when you put Markdown together with R code, you create documents that have data-generated elements. So you've both got text that's styled using Markdown, and then you've got things like figures, tables, and numbers that are generated from data or from code or from their combination. And RMarkdown is one of a broader trend of literate programming practices. This includes Jupyter notebooks, includes Quarto, which is kind of the next iteration of RMarkdown, so forth, that allow you to not just to write code, but also to document that code in a clear way. Okay, so what does an RMarkdown document look like? This is a screenshot of RMarkdown in the RStudio window. There are basically 3 kinds of things you'll see here. The top is the header, which sometimes is referred to as YAML. This is metadata about the document and how it's rendered, how it's going to be displayed. Then you see highlighted in gray with these 3 tick marks, tick, 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 these code chunks. This is R code that's going to be interpreted by R. And then the third component is formatted Markdown text. So here's a second level heading, RMarkdown, and then some text and links and bolded text and so forth, and then more code chunks. We can walk through each of these 3 sections. Headers are formatted text that tells RStudio and the knitter package the general properties of the document. You can customize these within limits, but generally you don't want to fool with them. It's very formatting dependent. So you just want to fill in the fields that are here and basically leave this header alone. Markdown text is where your paper goes. You can write in Markdown syntax with headings, formatting, bullets and lists, hyperlinks, and so forth. And you can also critically include R code chunks in line. So if you write tick R space 2 + 2 tick, then when you compile or knit this document, that code chunk will run and return the number 4. Last component is these code chunks. They're delimited by tick, 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 R, which tells RMarkdown that this is a piece of R code, and then some extra options, which we'll talk about a little bit later. And then they're ended by tick, tick, tick. And they should be formatted gray, so they're easy to see. And you can actually run them using the play button, you can add settings and so forth. And R will then execute the code inside the chunk, and the effects of that code get printed to the document. So the figures, the numbers, the tables, anything that this code generates appears in the document. Okay, so when you knit a piece of RMarkdown, it gets turned into some format. And the default output format here is HTML, hypertext markup language, which is the basic language of the web. So basically, the default here is to turn your code and data into a web page, which is easy to share with collaborators and post on the web. But you can also turn that web page into a Word document through the magic of something called Pandoc, which does a conversion from the HTML template to a Word template. So you can certainly email these to a collaborator as well. And PDF rendering is also possible. If you do this on your own machine, it's going to require installing some extra software. So we're not going to do that today, but we can do that using Posit Cloud. All right, now it's time to see this workflow in action. Again, each of these examples that I do is going to have a recipe on a slide. So you can open up the slides in your own browser and see those recipes even after they're not on the shared screen. And the first recipe is going to start on slide 41. So now I'm going to move over to this rendering a simple markdown recipe. And I'm going to go over to my Posit Cloud. So this is my workspace in Posit Cloud. And I'm going to open up this blank project called RMarkdown tutorial sample. So I haven't done anything here other than rename it. So it's very, very simple. We're going to start from basically this blank document as it loads up. Okay. So first, let me orient you here. Many of you, it seems, have seen R, and some of you, about half of you, use it frequently. So this is the RStudio window. We have a number of different panes here. On the top is going to be our environment history. I'm not so interested in that, so I'm going to minimize it. So over here is our code window. This is going to be where our markdowns and our scripts go. Then we've got our files and plots and viewer on the right-hand side, and the console down below. This is not the default organization for RStudio, but it is the organization I recommend because it puts the code and the outputs side by side. If you want to customize, you can go to View, Panes, Pane Layout. This is a minor point, but I find that organizing your desktop is really important for doing good coding. If you're coding in a teeny tiny little window, it can be hard to get a good view of what you're doing. Okay, so this is basically our blank RStudio project with nothing in it. And what we're going to do in this first recipe is simply look at the rendering functions of RMarkdown. We're going to do that by going to File, New, RMarkdown. So I'm going to select this RMarkdown. And what's going to pop up, it's going to say, hey, you need a bunch of packages in order to do RMarkdown. And it's a big, long list of packages. And I'm going to say, yes, I want to install these packages now. And all kinds of nice stuff is going to happen here that I don't have to deal with. It's installing all 37 packages. And thank goodness I'm not doing this on my own machine because who knows what would happen. But since I've done this before, I know that it's going to work just fine in Posit Cloud. Once these packages are done, I'm going to be ready to use RStudio. Just a side note here, when we use open source free software like R and RStudio, often getting everything installed on your local computer is like a big part of the battle. It's a big part of the issue. But doing that successfully then means you have access to a really wonderful tool. Okay, so let's do my new RMarkdown here. So I'm asked about title and author and date. So I'm going to say sample RMarkdown. My author is Mike Frank. And then my default output format is just going to be HTML for now. We can change this. So I'm going to hit OK to this template. And what I'm going to get is a bunch of stub text, a bunch of basic elements that look just like what I showed you. The YAML header, a bunch of code chunks, which are in gray, and then a bunch of formatted text. So now all I'm going to do in order to put together this code and this text is go up to the top bar here and hit knit. To save it, sample.rmd, hit save. And now we're going to render. My pop-up blocker is annoyed. And here's my viewer. So that YAML header turned into the title, author, and date. The formatted text turned into formatted text like this, including hyperlinks and headings. The code summary cars then ran and output in this window. And we even got a plot embedded. So if you successfully do this, I'm going to launch the poll. Tell us in the poll when and if you're able to successfully get this to work. And it looks like the vast majority of people are getting it to work, which is wonderful. And that means that you now know how to do RMarkdown, because that's basically it. I know you're like, why did I sign on to a 90-minute webinar when you just told me to hit the knit button? And the answer is, well, there's a bit more to it, but basically now you've learned it. So if you need to sign off now, great. You've achieved my main learning goal by knitting an RMarkdown. You put together code and formatted text, and it created a fancy looking document. Now all you have to do is put in your data and your actual text, and then you're in good shape. So fabulous. If you are having trouble with this, if it didn't work and you said no here, that's just a small group of folks, then you can ask in the Q&A or chat, and the TAs can give you a little bit of help. Okay, so I'm going to close this viewer window and go back to my slides. So that was our recipe number 1, and it looked like it was successful. Now, let's go to recipe number 2. Don't worry, this is going to get a little bit more vague as a recipe. So I'm at the end of this, you'll see exactly the code that I have. There's a link for in the slides for exactly the code I'll generate by the end of this. So what we're going to do is add figures and tables here, so it starts to look like a real data analysis. Okay, back to my RMarkdown document. So I'm going to get rid of all of this stuff that we came in with. It's a bold move, but I'm going to regenerate these things. So the first thing that I'm going to do is start a new code chunk and load my favorite library, which is called Tidyverse. Tidyverse is an amazing set of packages. There's much more about this in the experimentology book and all over the internet, because this is a fabulous set of packages that allow you to do lots of great stuff with data in R. And of course, it's free, like all of the things in the R ecosystem. So as soon as I saved with this command library tidyverse, RStudio told me that tidyverse is not installed. So I'm going to install it. And that's another 26 packages. But luckily, this is being taken care of for me. Now, I'm going to be analyzing the data set empty cars. So I'm writing Markdown here. I put this in ticks to make it render as code. And this is actually what I do when I'm analyzing data. Now, I typically write the story of my data analysis as I write the code, and that gives me a record of what I've done, as well as a nice write-up that I'm able to share with my collaborators. And I find that the time it takes to tape this out actually helps me get my thoughts straight for what I'm doing and why. So here's my second code chunk. So here's empty cars is the data set. It's built into the tidyverse. So I'm going to run this chunk here. There's lots of ways to run a chunk, but one is hit play. So tidyverse is now attached, loaded. And now if I run this chunk here with empty cars, I get a nice view of it. This is kind of an internal view. You can sort of see all of the different data in here. This data set is about cars. I know nothing about cars. Literally the only things I know about cars come from driving the one car I own and this data set. But we're going to do data analysis on cars. Okay, so there's empty cars. Let's say I want to make this into a publication quality table. Does it have is my car a Prius? No, it's older than that. It's an old Toyota. What I'm going to do is I'm going to use the knitter package, and I'm going to use the cable function, and I'm going to say digits equals 2. And this generates a nice looking table. So here's my Mazda RX-4 with 21 miles per gallon, a 6-cylinder engine. I don't even know what DISP is, and 110 horsepower. Okay. So that's my data set. I've now displayed my data set. So I say, here's a table. Okay, then after that, I'm going to, now I want a plot. So I'm going to use the ggplot package, which is part of the tidyverse. The data frame I'm plotting is empty cars, again. My aesthetic is on the x-axis, I'm going to put miles per gallon, the gas mileage. On the y-axis, the horsepower, how strong the engine is. And just for fun, for the color, I'm going to put the number of cylinders. I hear that more cylinders in the engine means it's more powerful. Actually, I might have learned that from this data set. Okay, and I'm going to add a point layer and a smooth with a linear model. Don't worry if you don't know this syntax, that's a different topic, but this is a nice kind of flexible plotting package. And so I'm going to run this chunk of code. And there is my plot. Looks like the bigger the engine, the lower the gas mileage. Maybe I should have flipped these axes. Maybe I should have horsepower here and miles per gallon here, because it's the horsepower that determines the mileage. Yeah, there we go. Okay, so the bigger the horsepower, the smaller the gas mileage, and 4-cylinder cars seem to have less horsepower on average, and there's some relationship there, maybe, but the others, it's kind of like once you know the number of cylinders, that tells you that the gas mileage is bad. An attendee asks, why do you have to keep typing tick, 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 R? That creates a code chunk, which can be independently executed. So I'm doing this kind of interactively in the notebook, or in the RMarkdown. So I'm running each of these separately and looking at the outputs. But when I hit knit, all of these will run at once, and you'll see the outputs. Yeah. If you don't have this text here, so let's say I get rid of it, now it's just RMarkdown. I can't even actually run it because it's just text. So by putting tick, 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 R, I'm saying this is our code, which can be run. And now I can hit the play button and get the graph. Okay. So now I'm going to hit the knit button. So I've got my figure in my table, and I hit knit. And you can see here's my header, then library tidyverse. I get the outputs from that. Here's my cable table of the entire data set. And here's my plot. And that's the output. Now, this doesn't look like a written up report that for public consumption, but this kind of report is nice for sharing with my collaborators because they can see what I did and a little bit of narrative data and then the plot outputs. And so graduate students in my lab often send me these RMarkdowns. Students in my course turn in their problem sets in this format. So this kind of lightly formatted text with code and data interspersed with narrative is actually really helpful for parsing and analysis, but it's not what we publish. Okay, let's try to clean this up into a more presentation-ready format. So So our next recipe is going to be adding reproducible statistical tests. And then our final recipe in this section is going to be to clean it up and make it look nice. So let's just quickly add a statistical test here. All right, so go down to the bottom here. By the way, let me make this a little bit smaller, or a little bit bigger so you can see it more easily. Okay, so let's add a statistical test. I'm going to do a t-test here. And I'm going to use the MT cars data, compare cars with 8 cylinders on their miles per gallon and cars with 4 cylinders on their miles per gallon. So each of these commands just takes that subset of the data that has 8 cylinders, gets the miles per gallon, 4 cylinders, miles per gallon. I'm going to do a t-test between those two. And you can see here the 4-cylinder cars have much better mileage than the 8-cylinder cars. So we're hoping this turns out significant. So I run it and assign it to cars T statistic. So the t-value is -7. Maybe I should make it +7. I'm comparing the 4s to the 8s. Okay, so T is 7, cars T parameter. By the way, let me just say that I'm going to p-hack this in some random way for this demo. Of course, if you're doing an analysis of an experiment that you've pre-planned, I encourage you to think mindfully about your statistics ahead of time, potentially registering an analysis plan and thinking through what you want to do, maybe even writing this code before you collect the data and then running it with the data. So I don't recommend just poking around like this. If this is your main analysis for your primary research hypothesis, much better to pre-plan, think things through ahead of time. But just for the purpose of this example, we've got 14 degrees of freedom and a very low p-value, p less than 0.0001. This is 10 to the -6. Okay, so I've now cached these values in the variable cars T, and that's going to let me write a narrative here that is really actually very useful. So I can write there are how many cars? Some MT cars. There are this code chunk many cars with 8 cylinders in the data set, and same code chunk, but with 4. Okay, so this looks like spaghetti the first time you see it, but critically, if you think about what's going to happen when we knit, this code chunk is going to turn into the actual number of cars with that number of cylinders in the data set. So it's going to render to whatever it is, 14 cars with 8 cylinders. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cars, maybe, if I counted right. Okay, and now I can write cars with 8 cylinders have significantly lower gas mileage than cars with 4 cylinders. And I've done my t-test, but instead of pasting in the numbers and rounding them by hand, which is error-prone, complicated, and could change if the data changes, I can actually render this in. So I say T of our cars T parameter equals our cars T statistic, P equals our cars T p-value. So that's pretty cool. So now if I render this, I hit knit. I think I'm having the same viewer issue. Let's hit knit again. I pop up. There we go. One more time. think it's angry because I had so many pop-up windows. There we go. Okay, so now I scroll down to the bottom and I get there are 14 cars with 8 cylinders and 11 cars with 4 cylinders. Okay, so I counted wrong. So it's good that I used a reproducible workflow rather than just pasting in my count. And cars with 8 cylinders have significantly lower gas mileage than cars with 4 cylinders. And I get this kind of long, ugly t value here, which I'm going to have to round. And then this p-value here. So I can now change the display of my numbers if I want. Going back to the code, I could say round the 2 digits, round to 2 digits, round to 6 digits, maybe. If I want an exact p-value in here, let's knit this one more time. So you see how I'm iterating on the report, but the code stays appropriately the same. Come on. This code stays the same and allows me to kind of keep a record of what I'm actually seeing. Okay, so T of 14, 7.6. Okay, and I still get scientific notation, so I'd have to change my settings to make that work perfectly. Okay, so that's our recipe for adding statistical tests in line, which is a really valuable way of cleaning up that reporting and ensuring that you never fail stat check because you're generating these things directly from the data. Now, the last thing we're going to do is just a little bit of styling here to clean this up and make it look good. And then we'll get our final RMD, which is shared here in the slides if you want to take a look at what I did. Okay, so we're going to add some chunk options. So as you recall, we were seeing the outputs here, which maybe we don't want to do. So I'm going to put a first chunk up here, knitter, ops chunk, echo equals false, message equals false, warning equals false. So this is just kind of a set of options that tells our Markdown and the knitter package not to put all the extra code in there and all these weird messages that come out and so forth, and focus on just the write-up. And I'm going to put a top-level header here, load empty cars data for analysis, and then maybe main analysis, sub-level heading plot, statistics. So this is starting to look like a write-up. Nice comment from Elena in the chat. You can write math in our Markdown. So if we want to look fancy, we could, it's going to make this look even a little bit more complicated. I could wrap this in dollar signs. It's going to look all nice and fancy. I could even write, you know, y some math like this in double dollar signs. This is a nice function that allows you to write and format math beautifully. So thanks for bringing that up, Elena. Okay, so now I have taken out all my code. I put in some headers, and I'm going to put in a pretty table of contents. And to do that, I'm actually going to edit the header here in the YAML. So I'm going to say the output is still an HTML document, but I'm going to say that there's going to be a table of contents with a floating table of contents. And if I got this all right, I'm going to knit, and it's going to look much prettier than before. But my chunk options are not working here. Thank you. My TAs remember how this works. And critically, I don't remember all this stuff. As you see, I get it wrong some of the time. What I do is I paste it over from other analyses. But now here's my rendered report. I've got my title and metadata, my headers. Oh, and this is included because I told it to echo and not echo anything below. And then here's my table, my main analysis, and my statistics with nicely formatted math, thanks to Elena's suggestion. Molly, to fix the error message, I added this $ set here, which I didn't remember. One of the TAs remembered it because they know this well. I would just paste it over from another place. So I would just copy these over. And I can add echo as a setting here. Okay, great. Oh, and how do you upload or import your own data? I would just hit the upload button here and browse. I'd choose a file from my stuff. So anything on my desktop or anywhere in my project folders could be included here. Okay. All right. So this is our last recipe for the basic RMarkdown piece. So now is a good time to pause and answer a couple questions. So I just answered the uploading and importing to Posit Cloud. It's just the upload button. And then we have another anonymous question. Is there any way of building in checks for your text content? So what if the changes in the data meant that the results for 4-cylinder cars and 8-cylinder cars were reversed or not significantly lower? That is a great point. So you can write text that then is no longer true. Fundamentally, this means that it is useful to actually, take a look and proofread. So I do, have to go back and look if I change the analyses to make sure that the things I said about the analyses are true. I don't have an automatic tool for dealing with that. Although if TAs or others want to share their ways of dealing with this issue, then then please do share. Another question here, can you recommend good guides for some of the RMarkdown formatting options? So to be totally honest here, I just Google RMarkdown chunk options and I get the page that RStudio provides on this. So actually that is what I do most of the time. Most of my coding is powered by Google, but there's wonderful resources online that come up very easily for chunk options and formatting options. So on the Python piece, Angie's and Alvin do this quite frequently, so they're answering that one. And then Dahlia asks about a citation manager like Zotero. That's our next section. So thanks for giving me a great transition question. Okay, our third part, writing reproducible papers here. So moving forward, really the end game of this reproducible workflow isn't just writing the report and providing it to your collaborators. You want to write your actual paper. And here's the workflow that we use in my lab. We write our papers in Markdown. We add references as we go. We write our analyses in R so they generate the figures, tables, and stats. We knit the final manuscript. The formatting into APA is handled by the template. The bibliography is automatically generated. And then as we make changes during revision or during our internal review, we change the code and we reknit. That's the basic workflow. That sounds like magic. How does it work? The basic package that makes it possible is called Papaya, spelled Papaja, because I'm silly American, but it's actually a German package written by Frederick Aust. It's an amazing contribution, and you pronounce it Papaya. So the basic idea behind Papaya is that managing APA formatting and bibliography is a pain, so you let the software do the work for you. With the Papaya package, you have an RMarkdown template for APA, and then that will knit to a Word or a PDF document. And this includes wonderful functions for formatting the statistics. So let's do a recipe on this. Again, we're going to basically just generate a formatted template and render it. And the instructions for this are on slide 49. So here's our recipe. I'll come on over, and what I'm going to do is make I'm going to install the package Papaya first. Install packages Papaya. I'm going to do this at the command line. And once Papaya is installed, I now can go to File, New, RMarkdown. And now the difference from what I did before is I'm going to go to From Template. And now because I installed Papaya, I have an option in my templates, API style manuscript 6th edition. Okay. And I get this template here, which now has a lot more in the YAML. Got titles, short titles, authors, affiliations, author notes, abstract, keywords, word count, all of this stuff. I'm not going to touch any of it. And then below, some code chunks and setup, analysis preferences, that same op chunk set. And then some APA headings and references. Okay, so we're not going to touch anything about this template right now. We're just going to do the magic thing of hitting knit. I have to say sample APA. So I'm going to knit this. And that template is going to turn into a PDF in submittable APA format. Title, authors, author note, contributions, correspondence, abstract, title, methods, participants, data analysis, results discussion, references. And even the bibliography has been auto-generated, including a citation to Papaya, because you should cite the R packages that you use. So I think that's pretty cool. Now, just to be super ultra fancy here, I'm going to take all of my code here that I generated before. I'm going to copy it, and I'm going to paste it into my sample APA in my results section, because I'm writing a really good paper about cars and their mileage. And now I'm going to hit knit again, and let's see what pops out. Okay, well, I could use some formatting help here. So I'm going to analyze empty cars. Here's my awesome table. Here's my plot. Here's my statistical test. Discussion. All I need to do is write a paper about this, and I can send it into Psychological Science or any of my other APA accepting journals and publish my brilliant analysis of empty cars. Harry asks if APA 7th will be in there. Yes, Frederick is actually amazing and really, really responsive. He's created a bunch of packages here, and so I imagine that it'll be available. That's right, Elizabeth, the table is not in the APA format. I'm going to have to go off script here, but we could give it a try if you want. So I'm going to do Papaya, APA, APA table. Let's try that out. Okay, and now I'm going to knit and see what happens. It's angry at me for some reason. Don't know why. It's probably not this. Let's try that one more time and see if it fixes it. And here's an APA format table. It's still too long. I could just put the first part of it in there if we wanted, but we're getting beyond ourselves. I could do a head of empty cars, and then it would really fit on the page. And I could probably set the caption. My general problem is that I don't stay on script. I just keep trying out different things. But hopefully I'm modeling the strategy of messing around and trying things out, and we'll see if this actually renders into a decent looking table, which it does. Here's table 1. Here's the empty cars data set, at least the first 6 rows of it. Okay, So that was our recipe. Now let's talk about the bibliography, because one major pain point for generating APA formatted papers is managing bibliography. Oh, by the way, I'm going to launch this other poll to see if your papaya knitting worked. So let me know if you had trouble with this. Okay, so a major pain point for bibliographic management is doing your references by hand. I admit I still sometimes do this, but it is not a great practice, and it's always annoying because you add a reference and then you forget that you stopped citing it, so then it's still in the bibliography and then the copy editor yells at you. Here is the alternative. You use a software library like Zotero, and you import citations to your library in Zotero, and then you insert them into your text with the bibliography being generated automatically at the end. So let me show you just a little bit of that workflow. I'm not going to show you the whole workflow because it can get a little bit more complicated, but I really strongly recommend that you do this. So you don't have to use Zotero. There are a bunch of different possibilities. Zotero, Mendeley is another. EndNote is one, although it's not compatible with this workflow as far as I know. And BibDesk is one for doing LaTeX bibliographies that I use, but I don't know if I recommend it. So the basic idea is you use one of these automatic bibliography building packages that creates a library, and then you export the BibTeX file from that. BibTeX is a specific format for sharing bibliographies, and that's going to have all your reference info. Then each paper in your bibliography, in your BibTeX file, has what's called a citation key. That's this @ here. So if you wanted to cite Tom Hardwick's reproducibility paper, you would write @Hardwick 2018 if that's the appropriate citation key. Then the software takes care of the rest. The software converts this into an APA reference with an appropriate bibliographic entry when you knit. Okay, so let's see that in action. So again, we're going to do a recipe here. I'm going to upload a bib file to Posit Cloud. I'm going to add the bib file to my YAML, add the citation to the document, and then knit. So here's my Posit Cloud. So I'm going to do that upload thing that we talked about before. Upload, choose file. It's on my desktop because I'm very organized. Here's library.bib, upload. Okay. So now library.bib is in my files window, so I can confirm that. And now in my YAML, I'm going to change my bibliography to library.bib. Save this. And now, all right, as @Hardwick 2018 noted, computational reproducibility is limited unless you share your code and data openly. Save. And I'm going to hit knit again. And here the magic should happen. Okay, so I'm going to go down to my introduction here. As Hardwick 2018, correct APA citation format, noted. And now in our bibliography, we have Hardwick 2018. It's clear that there's an issue in my bib file. So I have to correct the bib file to get this et al. Others thing right, that has changed a couple times and the journal's missing. So I'm going to have to clean up my bib file, but I can do that. And then no matter what format I cite this in, it's going to format correctly. Okay, that was the kind of the basic bibliographic management. And I admit that that's what I do I use BibDesk and I create a bib file and then I cite from it directly like that. But Alvin actually showed me yesterday how he does something much more awesome. He installs the Better BibTech Zotero add-in, which generates citation keys and better formatting and lots of other nice stuff. So that's an add-in for Zotero, which is, of course, linked in the slides here. And then he installs Frederick Aust's Sitter package, which is an RStudio add-in for citations that you can see happening in this animation on the right-hand side. So Sitter actually pops up a window that lets you sort through and search your bibliography and build the citation strings. So you don't have to remember those cite keys. It actually auto-inserts them for you. So that looks a lot like using EndNote or Zotero in Word. You hit Insert Citations, and then you go through your references in some connected to your Zotero, and then you can actually import these things really nicely. So that's pretty exciting and fun. And I encourage you to try this out if you're interested in doing auto citation. Okay, so we had a question earlier, which was answered by the TAs, but I want to talk a bit more about the issue of collaboration. So there are many models for collaborating using RMD. So you can do this in a lot of different ways. Some of them are basically as good as the old way of all just typing in a Google Doc or all just sending Word documents back and forth. But they are going to require a little bit of getting used to. So here are 4 different models. The first model I use most frequently when there is a first author who is kind of relatively senior and who's expecting high-level feedback on their manuscript. That's a case where the first author owns the RMarkdown document, maybe is archiving it on GitHub, but basically what they do is they just render a PDF and they send it to the co-authors. The co-authors read it and send back PDF edits or a list of changes or general discussion items. That works well if you want to do bigger edits, but it's a little bit annoying for line editing. Many people like track changes functionality. So the second collaboration model here, which my lab uses a lot, especially with more junior co-authors where we expect to do a lot of co-writing or co-editing, is that the first author drafts the paper, renders it to Word, imports it to Google Docs. We all collaborate on the Google Doc and we write together, especially on the introduction. And then the first author ports the text back to RMarkdown. This works pretty well because we wait until we converge and then we just paste the intro back in. And typically there's less iteration around the specific numerical results, although there is sometimes editing there. There's also the possibility of collaborating on RMarkdown using Git and GitHub. So each editing the RMarkdown and using Git as a distributed version control system to try to coordinate our edits. That's an advanced workflow, but it's one that we use as well sometimes. And then finally, there's the redoc package, which can actually bring Word track changes back into RMD automatically. I admit that we don't use this in my lab, but I've heard good things about it. Sorry. Okay, on to sharing. So why share your reproducible manuscript? I think I made this case earlier, but basically, if you just have data shared, analytic reproducibility is still really hard. So if you share the RMarkdown script to generate your paper alongside the data, that's a really great step for letting other people reproduce your work. It's going to be really helpful for secondary analyses as well for people using your data for power analysis or for meta-analysis or other creative reuses. Where to share? An easy, simple option is the Open Science Framework. If you share the code in the form of an RMarkdown and your data, that's a great solution for just sharing the reproducibility package. We, in my lab, use Git and GitHub, and this is documented in experimentology, and there's a nice guide for getting started. That also allows you to do version control, which is independently helpful. One big problem for reproducibility, even if you share code and data, is that sometimes software changes. So it's really important to document the versions you use for key packages. One way to do this is to print out the session info and include that in your reproducibility package. Or you could consider going fully reproducible and using the renv package, which is going to capture exactly which version of each package you use. And when somebody reinstalls it, it'll download those old package versions and make sure that they're being used to reproduce the document. So that's a great way to really get a very down to the number reproducible version of a document. Okay, just one more plug for the experimentology book, which is our free open source, open access textbook on experimental methods for psychology. It has a lot of open science content, as well as content about project management, data sharing, getting started with GitHub and Tidyverse and RMarkdown and so forth. So please do check this out if you're interested in a reference work. All right, so wrapping up, we're only human. Errors are inevitable. Some people make fewer errors. I happen to be sloppy and move fast. You see this in my typing. I make a lot of errors. And so it's really important to create workflows that minimize errors and maximize their chance of detection. Doing things by hand is a great way to waste time and make more errors, like rounding numbers by hand, pasting in statistics by hand. So if you write reproducible scientific papers, you avoid errors. It's not going to completely solve the issue, but it's going to help you avoid some of the common roots to error. It also saves time and energy, and it makes spiffy looking documents very easily. So that's the basic summary. Take your RMarkdown write-up, put it together with your data, and generate an APA paper. Thanks very much. Okay. We still have about 5 more minutes, so I'm happy to stick around and answer other questions if folks want to put questions in the Q&A. The recording will be available. The slides have all the recipes and links to the code. And of course, the broader issues are covered on experimentology. Okay, thanks everybody for the kind words. Okay, Aaron asks, weird issues with references. So you get some kind of funny knitting. Aaron, the first thing that I would look at is go to the bib file that you're using and check that the references are correct. So if I go in my Posit Cloud here and I open up library.bib, and I'm actually going to search that Hardwick 2018 paper. This is that citation. You can see that and others was manually added there. That's kind of lame. And it doesn't have a journal. So there's a bunch of stuff that's missing here that's causing these issues. So if I fix these, the citation will look better. The bib, if the bib is correct and the rendering is weird, that could be a styling issue with the particular template you're using. Yeah, that might get into the BibTeX, the particular way that the BibTeX is getting rendered. So once you've confirmed that the BibTeX entry is correct, there may be something about the template. Sorry, I'm not exactly sure. Okay, so the an anonymous attendee asks whether there's similar templates supporting the Elsevier class. That's a good question. So there is a LaTeX class for Elsevier articles. And I believe actually that somebody in my lab put together an RMarkdown template for this as well. I would have to look that up offline, or maybe the TAs can Google Kyle McDonald's Elsevier article class RMarkdown. We had a question, how to start smaller than a full manuscript. Yeah, that's a great question. And my recommendation here is actually that you start by, as Angie said, doing the results section in RMarkdown and writing the rest in Word or in Google Docs, and then potentially at the end kind of pasting it in to this sort of template. So that can be a really easy way to do things. The alternative is to render your results and paste them into the Word document, but then you end up with some kind of other issues down the road. So that can be kind of complicated. So I recommend kind of starting by writing the paper normally and then using this as the kind of formatting and reproducibility at the end. Aaron, thanks so much for asking. I think we are thinking about doing a project management ManyBabies workshop for doing data storage and archiving, preparing yourself for sharing, thinking about integrating pre-registration into the workflow. So that's hopefully what we're going for next. Okay. Thanks very much, Aaron, for the kind words. Making Shiny apps is definitely another possibility. I think that's a bit more specialized, but we'd be happy to show some of the methods that we do for that. So that's certainly a fun topic for kind of advanced tidyverse. Okay, thank you so much, everybody, for joining. This concludes the official portion of the webinar. So as I said, we'll share the recording and the slides, and thanks again for coming.